We are discussing second year mathematics. In 4.3 we have discussed question number 1. Here we will discuss question number 2 of this exercise. In this question, find the critical values of the following functions. So we will find the critical values of the function. For finding critical values of the function, we will take the derivative of this one. F prime of x is equal to 6x square minus 6x minus 72 plus 0. For critical values, put f prime of x is equal to 0. So this will become 0 is equal to 6x square minus 6x minus 72. We will take common 6 here, 6x square minus x minus 12. So this will become, dividing 6 on both sides, x square minus x minus 12 is equal to 0. By factorizing this expression, x square minus 4x plus 3x minus 12 is equal to 0. X common, x minus 4 plus 3 common, x minus 4. So x plus 3 and x minus 4. X plus 3 is equal to 0 and x minus 4 is equal to 0. So x is equal to minus 3 and x is equal to 4. So these are the critical values of the functions. Question number 2, we have part B. Question number 2, f of x is equal to 1 divided by 3 x cube minus x square minus 15x plus 6. By taking derivative of this one, f prime of x is equal to 3 divided by 3 x square minus 2x minus 15 plus 0. So this will become f prime of x is equal to x square minus 2x minus 15. For critical values, put f prime of x is equal to 0. So this will become x square minus 2x minus 15 is equal to 0. By factorizing this, x square minus 5x plus 3x minus 15 is equal to 0. X common, x minus 5, sorry, and this will become plus 3 common, x minus 5. So this will become x plus 3 and x minus 5 is equal to 0. X plus 3 is equal to 0 and x minus 5 is equal to 0. X is equal to minus 3 and x is equal to 5. So these are the critical values of this function. Similarly, part 3 of question number 2. C part of question number 2, f of x is equal to 6x2 divided by 3 minus 4x. So by taking derivative of this one, f prime of x is equal to 6 into 2 divided by 3 x 2 divided by 3 minus 1 minus 4. So this will become 1 and this is 2, 4x, by taking LCM, 3 LCM, 2 minus 3 minus 4, and this will become 4x minus 1 divided by 3 minus 4. So we will put f prime of x is equal to 0 for critical values. So this will become 4x minus 1 divided by 3 minus 4 is equal to 0. By taking 4 as a common, 4x1 divided by 3 minus 1 is equal to 0. Dividing 4 on both sides, x1 minus 1 divided by 3 minus 1 is equal to 0. So x minus 1 divided by 3 is equal to 1. So this will become 1 divided by x 1 divided by 3 is equal to 3. By cross multiplying, we have, by cross multiplication, this will become 1 is equal to x 1 divided by 3. By taking cube on both sides, here we will take cube and here we will take also cube. So this will become, this cancel with this one, this is equal to 1. So the critical values of the function x is equal to 1. So for next part, question second, D part, f of x is equal to 3x 4 divided by 3 minus 12x divided x power 1 divided by 3. By taking derivative of this one, f prime of x, this will become 3 into 4 divided by 3x 4 divided by 3 minus 1 minus 12 into 1 divided by 3x 1 divided by 3 minus 1. So this will become 4x 4 minus 3 divided by 3, taking LCM, minus 1 is 4x 1 minus 3. So this will become 4x minus 1 divided by 3, sorry, 1 divided plus 1 divided by 3 minus 4x minus 2 divided by 3. So this will become 4x 1 divided by 3 minus 4x power 2 divided by 3. By taking LCM of this one, this will become x 2 divided by 3 4x 1 divided by 3 dot x 2 divided by 3 minus 4. So this will become x 2 divided by 3 4x by adding these two. So this will become 1 plus 2 divided by 3 minus 4. So this will become 4x 3 divided by 3 minus 4x 2 divided by 3. So this will become 4x minus 4 divided by x 2 divided by 3. This is f prime of x. For critical values, put f prime of x is equal to 0. So 0 is equal to 4 common x minus 1. So by cross multiplication we get this is multiplied with this 0, and 4 x minus 1 is equal to 0. Dividing 4 on both sides, x minus 1 is equal to 0, which implies that x is equal to 1. So the critical value is equal to 1. So in this way we can find the critical values of the function. Now we will discuss question number 3 of this. Question number 3 of exercise 4.3. Determine whether the given function has a relative maximum, a relative minimum, or neither at the given critical values for the following problems. Okay, so we have a function f of x is equal to x3 minus 3x plus 1 whole power 7, and at x is equal to 1 and x is equal to minus 1. For relative maximum and relative minimum, the function has relative maxima or maximum at x when f of x double prime is less than 0, and function f of x have relative minimum at x when f double prime of x is greater than 0. So we will take double derivative of this function and put x is equal to 1, and then put f double prime of x is equal to minus 1. First of all, we will take first derivative of the function, which will become f prime of x is equal to 7 x cube minus 3x plus 1, 6 into 3x square minus 3 plus 0. So now we will take second derivative of this function, f double prime of x, f double prime of x, f double prime of x will become 7. We will apply product rule. Here we will apply product rule. First function as it is into derivative of second plus second function as it is into derivative of the first. Derivative of the first will become x cube minus 3x plus 1 whole power 5 dot 3x square minus 3. So this is the second derivative of the function. Put x is equal to 1 in this equation. When we put x is equal to 1 in this equation, you will find f double prime of 1 is equal to 7, and 1 minus 3 plus 6 whole power 6 dot 6 plus 3 ones are 3 minus 3 into 6 into 1 minus 3 plus 1 whole power 5, and this will become 3 minus 3. So here this is 0, so this all become 0. Okay, so here 7 into minus 2 in plus 6 plus 6, this will become 7 minus 3, this will become 4 power 6 into 6. Okay, so here we will see that f double prime of 1 is greater than 0. When you solve this, you will find a number greater than 0. So f double prime of 1 is greater than 0. So the function have relative minimum at x is equal to 1. Now we will check for f of minus 1, f double prime of minus 1. So f double prime of minus 1 will become 7 into this will become minus 1 plus 3 plus 1 whole power 6 into 6, sorry, minus 6. This will become minus 6, and plus 3 into 3 minus 3, and 6 minus 1 plus 3 plus 1 whole power 5, and 3 minus 3. So similarly, this all becomes 0 due to this 0, and we are left with only this one. So this is 0, this is 0, this is minus 6, and this will become 7 into minus 6 into 3 power 6. So minus 42 into 3 power 6. Here we see that f double prime of minus 1 is less than 0. So the function have relative minimum, sorry, relative maximum at x is equal to minus 1. So this is the answer. So at x is equal to 1, function is minimum, and at x is equal to minus 1, function is maximum. In this way, you can find all the parts of the this question, B part, C part, and D part. All are similar. So in the next video, we will discuss next question, inshallah.